Hi everyone, this is Victor and I'm going to take you through the Gen AI journey. It all started 3 years ago when ChatGPT showed everyone that computers can understand language. And it was really completely mind-blowing that all of a sudden you can talk to a computer. It will seem to understand what you say and will give you compelling answers. And the way LLMs work is they are able to predict the next word accurately, so they have no understanding of anything, but they're able to sound like they understand everything. And in particular, one of the common use cases would be to go to ChatGPT instead of going to Google, because you can just ask a question and you'll get an answer. Sometimes right, sometimes wrong, but you'll get an answer. And then you can do anything you like within the prompt. So you could ask it to translate from one language to another. You could paste a legal document and ask to extract certain clauses or summarize it in simple language. You could ask to draft an email from bullet points and so on. Then the next step of the evolution was to retrieve the right context before having LLM produce an answer. So in this chatbot style, the LLMs themselves, they were using their internal knowledge in quotes, and they could never reference where the answer is coming from. But the technique called retrieval augmented generation, or RAG, is what enables LLM to ground their answers in whatever information is relevant and provide references to that information. So the key here is the first step, which is retrieval, when you, instead of just asking the LLM to use its own knowledge to respond to the question, you are retrieving the information first, giving it to the LLM, and then the LLM uses that information to phrase your answer, and it can point you to which bits of the information you provided it used. So you could, for example, just make a call to a search engine and get search results and get description of those search results, and perhaps get content of the pages that those search results point to. And from those, say, top 10 documents, you could find the answer, and you could say where the answer is coming from. Alternatively, you could use something called semantic search, where it's not standard web search, it's actually search that understands meaning. And for that, you need to do a bit of work in advance. You need to index whatever knowledge you want to search over, for example, all of your files on SharePoint, and then you would search would understand what you're asking about, will return the relevant bits, and then the job of the LLM would be to just phrase the answer using the information provided. Alternatively, it could be an API call to, say, Salesforce or to whatever platform you're using to get some relevant data. Then we're moving on to a new territory where LLM can not just answer questions without references, with references, but can also do certain things. And it can also not just do certain things, but it can answer more questions. So, for example, if you give LLM the ability to find out what the current weather is at a given location, then it will be able to answer the question, what's the weather in London next week? It is a heat wave, by the way, so enjoy. And it also allows LLM to call what is called tools, which is basically ways to do something like get the current weather, but the tool could be draft an email or send an email or check something in the calendar or execute this code that the LLM may want to write. And the results are fed back into the LLM context, and just like in retrieval augmented generation, the LLM decides, produces an answer using that context. And then we get into the very modern age, which is agentic AI, where there are use cases where LLMs also have autonomy to decide how to accomplish the task, beyond just choosing which tool to call. And the best example of this is coding tasks. And this is where you're just phrasing what you're trying to code in simple language, as if you were describing it to a colleague, and then the LLM enters this so-called agentic loop, where first it figures out if it needs to collect more information, then it makes a plan, then it takes an action, then it verifies the results, then it perhaps runs the code, gets an error. Actually, this is a more detailed description of what actually happens. So you tell it what you want to do, for example, implement certain algorithm. Then the LLM will generate some code, it will run it. It will perhaps, the first time it tries it, gets an error. And then it will send that error back into the prompt. This is the code, this is the error, fix it, and it will iterate until it actually produces the results that seem to be correct. Let's take it into the business context and out of the purely coding context. Let's say the problem is that you want to extract some numbers from, say, annual reports, and annual reports may come in a variety of PDF formats, and the way that is a safe way to approach these types of problems is to start with the question, how will I know that the solution is correct? And that's something called an eval set or a golden set, and you can actually use AI to help you create that golden set, but you need to verify it. But once you have the golden set, which in this case would look like the total interest income for 2025 is 51,049. And then you ask, in this case I'm using Claude Code, which is the most popular tool at the moment, to iterate, to actually come up with the solution. And you tell it to iterate, to propose a solution, run it against the validation set that you just put in place, analyze the mistakes, then update the solution, and keep going until it gets to ideally a perfect score on the validation set. And the validation set looks like this here, where we're just providing correct values for the different extracted values. So we start with the golden set. Ideally, you would also give it some guidance. So you wouldn't just tell it this is the problem, solve it. You will give it a high-level idea of how to approach the problem. For example, you may want to say convert PDFs to Markdown first, and then use LLM to extract numbers from Markdown. And then Claude Code implements the solution. It compares the solution to the golden set, and it iterates. And it will, as it's doing it, it will explain to you the design choices that it's making, and it may actually help you figure out some of the things that you need to instruct it to do, depending on what it found in the files. So it's also kind of a discovery tool for understanding the data and for understanding the requirements. The key point of all of this is start with the eval. Start with asking yourself, how will I know it's working correctly, and create a golden set. And this is at the core of everything that we do, and this is probably the single most important component that makes AI projects much more likely to succeed and remain successful in production. The ability to evaluate things automatically, not manually. So in this eval-driven approach, there is automated evaluation where starting from the golden set, which could be specified as for the question, what is the order of operation in object script, the instructions, so the correct answer should say strictly left to right. Then we ask this question. The current chatbot or solution gives you the answer, and it's this long answer. And then the LLM as a judge is used to decide whether the answer that was provided is consistent with the correct answer mentioned in the instructions here. And it explains its judgment, so it's giving you a very quick way to check why it decided that the answer was correct or incorrect, and in this case instructions correctness is correct. And the beauty of this is that you are able to run it automatically. It can be part of your CI/CD pipeline, meaning that whenever you make a change, before that change goes into production, it automatically is evaluated against your eval or your golden set. Then another dimension that is often important for practical applications is guardrails. And this is what allows you to have almost 100% confidence that certain things are true. And this is something that you can build on top of any LLM decisions, and this is something that's built into our framework that allows you to specify the properties that must be validated before the answer is provided. So at the moment, the state of Gen AI is such that it's moving extremely fast. And what that means is that solutions become obsolete very fast. And there is something new that just works way better than something that did not exist a couple months ago. That's one point. Another point is that vertical AI solutions, so different solutions for different business problems provided by different vendors, are hard to adopt. It takes a lot of time to onboard a new solution. It takes a lot of time to ingest the right data, and then chances are that by the time you're done with it, there is something much better that you cannot really use until you onboard it. And on the other hand, doing this in-house is very expensive and slow, and you're reinventing the wheel all the time. So there is so much noise, and there are few things that are universally true, if they exist at all, because the field is moving so fast. At the same time, there is this growing FOMO that someone is doing something with AI, and if you don't start doing it now, then we're gonna be out of business. The approach that we advocate that minimizes this Gen AI risk starts with picking the right use case. Then defining success criteria, defining the golden set or the eval, and defining the metrics that would be tracked after the solution is rolled out, and the ROI. So you create a golden set, you automate evaluation, and you iterate very fast, and it's completely possible with Gen AI. So it shouldn't take you more than 2 weeks to go from the well-defined problem to a solution that can be tested. You can add guardrails, because in many cases there are valid concerns that AI may not do a good job. If it's wrong given one time out of 1,000, if you can be sued for that, or if it leads to very bad outcomes, that's not acceptable, and that's where guardrails come in. So iterate fast means prove that it works after a few iterations, and then a crucial part that addresses the adoption question, embed it in existing workflows so that it's unavoidable. For example, in the customer support case, embedding it into existing workflow means the user may be entering a ticket in the same interface, but then before they're able to submit the ticket, they get a suggested solution, and they have to click either I'm all set, this solved my problem, or submit the ticket. And then monitoring is also important to see, especially to look at feedback. And once you're done with one use case, you move on to the next. And the key to success here is breaking down the problem into small pieces. I'm talking about the key to success in terms of technology. LLMs are incredibly smart and incredibly stupid at the same time. So getting the simpler the tasks that you give it, the better the chances are that you'll actually get to a reliable performance. Then you really want to have this golden set, and you want to be able to run it multiple times, and you want to be able to incorporate user feedback easily into the eval sets, especially the negative one. You want to make it very easy to switch between models. One simple reason is that models become obsolete very often now, and retired, and then you need to go to the next model, or you may want to switch to a cloud model in AWS if OpenAI models in Azure are not available, which actually happened to us in one of the regions not so long ago, and then integrate into existing workflows so that users kind of have to use it and don't need to open another window. From the security point of view, many organizations don't have the luxury of letting their data leave their infrastructure. And ideally, for the most sensitive use cases, they don't really have the luxury of having anyone touch that data. So what we provide is an on-prem or within your infrastructure solution that can be self-managed. So your team can self-manage the solution. We could set it up or configure it based on some sandbox data, and then you take it into production where only you have access to the data. We never take your data outside, so we're not software as a service. It's always within your infrastructure. And we are not locking you into a particular LLM, a particular cloud provider, or a particular vendor. So it's very easy to adopt new models, tools, frameworks, and whatnot. And also we are a white box, so your internal teams can review and test whatever we ship. We also provide the control plane that includes observability, auditability, and delivery and controls. So that can help your risk teams understand exactly what's going on and be comfortable with it. Resilience is important to many companies, and the concern about a certain model becoming unavailable is valid. So having a plan on how you fail over if one model goes down in one region, do you fail over to the same model in another region, do you fail over to another cloud provider, do you fail over to another server within your infrastructure where you run open source models. All of that can be built into the solution. And because it's all transparent, you can see which dependencies are there, and you can test each part, and you can make components substitutable. You can also guarantee the standards alignments with the existing frameworks that govern AI deployments. To talk about one of the case studies, one of our customers, a company called Porforce Software, they're very big in the DevOps space, and they won 2 industry awards for using AI in customer service called Stevie Awards. And the AI that they won the awards with is built on our technology, and they're using solutions that we provide across many use cases. So it's an example of being a single AI layer across all of the use cases where there is no lock-in and you don't need to onboard different vertical vendors. You can take an example at a public chatbot at help.puppet.com, and there's a full case study on our website. Another case study is a company called IntraSystems that decided to use us for the RAG technology across their projects, and they have many teams that are building great AI solutions, but it helped them to unify the disparate projects around RAG so that everything goes through Serenity, and that helps them move much faster. And we're able to integrate with their own technology, Iris Vector Search, which is an extremely performant way to do retrieval. We are very flexible when it comes to how we engage. We could just engage as consultants for as long as you need, a couple of hours, half a day, couple of days. And we're not going to promote our services, we'll just advise you on what's best for you. If you do decide that our services suit you, then we'll run a quick pilot along the lines that we discussed of how we engage. We iterate fast we start with the evaluation set. And then we could help you with a longer phased rollout. What we find many companies benefit from is the initial consultancy bit, where we help them with the high-level AI strategy, identifying the first AI use cases and defining the success criteria. If you have any questions, feel free to reach out. And thank you very much.